Let's say that you want to check to see if some data is greater than another value. So for example, we could do x less than dash 5. So now x is 5. And then if we want to check if 4 is greater than x, we just type that out. We do 4 greater than x. We get false. And then we can also do other values as well. So it's either true or false. If you like this, please like, comment, and subscribe. Let's say that you want to check if a number is less than a variable value. To do that, we first create some data doing x less than dash 5. And then we can check if 4 is less than x by doing 4 less than x. Enter. It's true. So then if we were to say change this 4 to a 10, it's now false. If you like this, please like, comment, and subscribe.
Let's say we want to check if some data is equal to another value. So for example, we have x less than dash 5, so x is 5. We wanted to evaluate if x is equal to 4, you do 4 equals x, and then it's telling you that it's not equal to 4. But if you did 5 equals x, you would get the true value.
If you like this, please like, comment, and subscribe. Let's say that you want to check two logical statements and see that they're both true. To do that, we can use the AND operator. So to set this up, we can do x less than dash 5, and then y less than dash 10. So now we can do our first AND operator by doing x equals 5, and, so two AND symbols, and then y equals 10. So this is true because both of them are true, because if we go up and over and change this 5 to a 4, this x is not equal to 4, therefore the whole thing is false. If you like this, please like, comment, and subscribe. Let's say that you want to check if one statement is true or another statement is true. To do that, we can use the logical OR. So let's create some data doing x less than dash 5, and then y less than dash 10. So now x and y are 5 and 10. So then if I want to check if x is equal to 5, or line, y is equal to 10, and then I can hit enter, and it's true. X is equal to 5, or y is equal to 10. In this case, they're both true, but if I were just go up, change this to 4, so now x, which is assigned the value of 5, is checking is x equal to 4. It is not, but this statement is still true because y is still 10. So if I change this to 9, then it becomes false. If you like this, please like, comment, and subscribe. Let's say that you want to filter out a subset of your data in R. To do that, let's first load some iris data set. So we'll do data iris. We can see that the dimensions of the iris data set is 150 rows by 5 columns. So let's say the rows that we're interested in are from the sepal length column, and we only want those rows that are greater than 5. And then we're only interested in the columns that are 1 and 3. So then to get that subset, we can just do iris bracket rows comma cols bracket. And then without showing all of the data, we can just do the dimension of this data. So now we can see we only have 118 rows and only 2 columns. So if you like this, please like, comment, and subscribe. Hello, today I want to talk about the isNA function. NA values occur when you have missing values in your data set, and the isNA function will identify the location of those elements within your data. So let's see how this works by looking at a toy example. So I'm going to create some data. I'm going to do my data less than dash c paren 1:3 comma NA comma 1:2 comma NA. Enter. And then if I do is.NA on my data, I can see that it's giving me false and true statements where it's true if that position is an NA value. Now we're going to work towards just getting those values that are not NA. So first step, I'm going to save these values to a vector called vals less than dash is.NA paren my data. And then I'm going to just present the values that are false. So I'm going to do my data bracket vals equals false. So now I just have the values that are not NA. If you like this, please like, comment, and subscribe. Hello, today we're talking about the which function, which can help find data that satisfies certain logical conditions. So for example, let's create some data first. Let's do values less than dash r norm paren n equals 10. So we have some standard normal observations here. And then I want to know which ones are large. And so LRG equals which values greater than 0.50. And then if I were to look at large, I have those values that are greater than a half. So then if I want to pick out those values that are larger than a half, all I have to do is do values bracket LRG bracket, and then I have those values obtained here. And then if I don't want those values, I can just do the same thing, except have a minus sign in front of LRG. Hit enter, and now I have those values displayed. So I hope you like this video. Please like, comment, and subscribe.